Hey guys, today we're doing chapter 11, sections 9 and 10, and I've kind of bundled sections 9 and 10 together because they're basically doing the same thing, and they're all talking about the polynomial difference theorem. So as long as you know how to use the polynomial difference theorem, you should be able to do both sections of homework. So the polynomial difference theorem states that the function y equals f of x is a polynomial function of degree n if and only if, for any set of x values that form an arithmetic sequence, the nth difference of corresponding y values are equal non-zero. Okay, I know that doesn't really make a lot of sense, but let me just explain it a little easier. So what this means is that linear functions will have a first degree difference, quadratic functions will have a second degree difference, cubic functions will have a third degree difference, and etc., etc. Nth degree functions will have an nth degree common difference. So essentially, if we can figure out what type of difference these functions have, we can then come up with a formula for this function using the fact that we know that it's linear or cubic or quadratic or quartic. Okay, so once we find those differences, we can actually come up with an equation for this function. So the way that I've written these notes here is I've given you the equation, so right away you know that it's going to be linear or quadratic or cubic. Okay, but in your book on your homework you won't know that. You won't have the equation. I just wrote it there so you guys could see where these numbers were coming from, and then we could relate it back to what we already know. On your homework they'll just give you a table and they'll say, hey, what type of function is this? Give me an equation. Okay, so this first one here, I've got this equation 5x plus 3, so I know that this is linear and it should have a first degree common difference. So what I've done here is I've got a table of values for this function. So if I plug in a 0, I get out a 3. If I plug in a 1, I get out an 8. Okay, so what I'm going to do, normally you'll just have this table, and what you're going to go do is you're going to find the differences for each of these terms. Okay, so the difference between 3 and 8 is 5. The difference between 8 and 13 is 5. 18 and 13 is 5. 5. 5. Okay, so what you notice here is that I have a first degree common difference. That means that the first set of differences that I found was all the same. They're common. Okay, so that means I stop. I know that this is a linear function. So now that I know that this is linear, I can come up with an equation. And the way I'm going to do that is using my graphing calculator. So on my graphing calculator, I'm going to start by going to Stat, okay, and then you're going to hit Enter at the Edit screen. And then on your List 1 and your List 2, you're going to go through and you're going to type in those values of that linear table. So for my x values, I have 0, 1, 2, 3, 4, 5. For my y values, I have 3, 8, 13, 18, 23, 28. Okay, so now that I've got those values entered into my table, now I'm going to go back to Stat, I'm going to arrow over to Calc, and then I'm going to go down to LinReg. And I'm going to use a linear regression because I know that this function is linear because it has a first degree common difference. So then when I hit Enter and hit Enter again, it gives me the fact that this function is going to be 5x plus 3. Well, looking back, 5x plus 3 was exactly the equation that I used. So I know I've done this right. Okay, and again, normally I won't give you this information. I'll expect you to come up with it on your graphing calculator, but that's essentially how it's done. So that was easy because that was linear, but let's do maybe a little bit harder function using a quadratic. So this one is x squared plus x plus 3, so I know that it should have a second difference. Okay, so I'm going to start 5 and 3, that difference is 2. 5 and 9, that's 4. 9 and 15 is 6. 8, 10, 12. Okay, so you'll notice that this first difference here was not common. That means that it's not all the same numbers. So that means I need to keep going. So now I'm going to find the differences of these numbers. This one's 2, this one's 2, 2, 2, 2. So that means I have a second degree difference, which means that this is going to be a quadratic function. So now what I can do is I can find the equation of that quadratic function using my graphing calculator. So again, I'm going to go into Stat. Then I'm going to go into Edit. In my list 1 and my list 2, I'm going to enter in those values on this table. So in my list 1, I've got 0, 1, 2, 3, 4, 5, 6. Okay, so now I've got all my values entered in there, and I know that this is going to be a quadratic, so again I'm going to go to Stat, Stat, I'm going to arrow over to Calc, and I'm going to go down to my quadratic regression this time. So now I've got my quadratic regression. I'm going to hit enter and enter again, and this time it tells me that I have x squared plus x plus 3. So if you look back at our table here, x squared plus x plus 3, that's exactly the function we had. We have done this correctly. Okay, next up we're going to do a quadratic regression to verify this function. Okay, this one is a little bit trickier just because some of these numbers are negative. So if I want to find the difference between negative 10 and negative 7, I take negative 7 minus negative 10, so that's negative 7 plus 10, which would be positive 3. If I want to find this difference here, that's 8 minus negative 7, so that's 8 plus 7, which would be 15. Okay, 47 minus 8 is 39. 122 minus 47 is 75. 245 minus 122 is 123. 428 minus 245 is 183. And 683 minus 428 is 255. Okay, obviously my first difference didn't work out, so I'm going to keep going. 15 minus 3 is 12. Okay, 39 minus 15 is 24. 75 minus 39 is 36. 123 minus 75 is 48. 183 minus 123 is 60. And 255 minus 183 is 72. Okay, second difference still didn't work out, so I'm going to keep going. 12, 12, 12, 12, 12. Alright, so I found a third degree difference. That means that this is going to be a cubic regression. So in order to verify what the function is, I'm going to go ahead and I'm going to go back to my stat, edit, I'm going to type all these in, and this time I'm going to use a cubic regression. And hopefully when you do that, you come up with 2x cubed plus x minus 10 and verify that this function is done accurately. Okay, notice that if we don't have enough data points given to us, it can be difficult to determine a pattern. And there's an example of that on page 733. Basically, if you go down and let's say that this third degree difference here didn't work out and I had to keep going, well, if I keep going, now I'll only have 4 data points. And then if I have to keep going from there, I'll only have 3 data points. And then if I keep going from there, I'll only have 2. And then eventually I'll only have 1. Well, if you still haven't found that common difference, or you can't prove that it's a common difference by the time that you only have 2 data points left, then you don't have enough information to determine the equation of the function. So sometimes you won't have enough information and you will just have to say, I don't know. Okay? All right, that's everything for sections 9 and 10.